This time I am going to discuss with you the singly linked list implementation in Python, and specifically I will be using a Jupyter notebook to discuss the code. So I have already installed Jupyter notebook in my laptop, so I would use the offline, not the online Jupyter notebook. To do that, I need to go to the command prompt and I will just type in Jupyter notebook and press enter, and it would redirect me to the browser. And take note that this is localhost, meaning it's not online. It is just an offline browser in my laptop. And let me go to documents and to CPE 211 first sem folder and open this Jupyter notebook. So we have here, as discussed in the previous video, this is how we define a singly linked list node as a class. And this is the constructor of the class. We have here a parameter value, which is the new element to be added into the singly linked list. And to do that, we create a node. So the self keyword here refers to the new instance of node we are going to create. So that new instance, that value will be assigned that value which we provide here in the parameter. And then the second field, which is next node, the pointer to the next node is initially none. So this is not yet connected to the singly linked list. And then in here, we define a function that allows us to insert a new node containing this new value to the tail of the singly linked list with a head node head. We have here some comments, 3 lines. This inserts a new node with value at the tail of a singly linked list with head node, which is called head. And this returns the new node as the tail of the new list. So how do we do that? So let's trace this one first with the first line, that is L1 gets node. L1 gets node 1. So take note that this is calling the constructor of class type node, passing 1 as the value. And so if we go here to the definition of class node, we are like creating a new instance of node. So this is what we call L1. It has 2 fields, value and next node. This is value and this is next node. So L1 this time, that value is set to this value, which is 1. So we have 1 there. Look at the code. The next node is set to none. So this is 1 and this is none. Okay, so we call this node L1. And then the next line is a function call to function insert tail, where the 2 parameters passed are L1 and 2. So let's jump to the function definition for insert tail. So the value of head is L1. So when execution jumps inside this function, L1 is referred to as head. This is now called head. So when outside the function, this node is called L1. When inside the function, this node is called head. Head and temp are just like local variables, active only when execution is in the function insert tail. So we have local variable temp, which is set to head. And so this node now, which is called head, is also called temp. So this node has 2 reference inside the function insert tail. It is referred as the head and it is also referred as temp. But outside the function, this node is referred as L1. And then we have here a while loop, and the condition says while temp.next node. So while this is true, do this. But what is the value of this temp.next node? This node is temp, and so temp.next node refers to this. This is temp.next node, the next node field. Notice that it is equal to none, and none is equivalent to Boolean value false. The none value is equivalent to Boolean false, and the not none is the Boolean true. So since at this moment temp.next node is none, then this is false. So the loop body is never executed, this one here, since the condition is false at the start. So execution jumps here outside of the while loop. In this line, we are creating again another instance, new node of class type node, and the value, which is, what is the value of value? It is 2 in this line. We pass the value 2. So we are creating now a new node. Okay, we call this new node. This node is called new node, and the value of this is 2, and this is none. And then next, we make temp.next node to point to new node. So temp.next node is this one, right? Temp.next node is this one. And then we make it to point to new node. So that is the effect of this statement. Temp.next node points to or is set to new node. Therefore, temp.next node will point to new node because the memory address of this new node is assigned to temp.next node. And then after that, we return new node. So take note that this function insert tail will return the new node as the tail of the new list, meaning it returns the new node that was recently inserted at the tail of the singly linked list. And then we again call insert tail. This time we pass the value 3 as the new element. We're going to insert a new node at the tail of the singly linked list whose first node is L1 and the new element to be inserted is 3. So our statement now is this one, the third line. We call insert tail, and we want to insert a new node having a new value 3 at the tail of the singly linked list whose first node is L1. So we trace this again. Temp, the head now is this L1. The head is L1, this one here. And then temp is set to head, so this node is also called temp. And temp.next node is this one, right? This time our temp.next node is not equal to none, okay? Because it is pointing to the second node with element 2. And since that is not false, we execute this one. So we make temp to point to temp.next node. So what is temp.next node? Temp.next node is referring to this node. The whole node here is called temp.next node. This is actually a memory address of this node, which is assigned to this value here earlier. So this is temp.next node, and we call this temp. So this is no longer our temp, but this is now temp, not this one anymore. It's like we make temp to move to this next node. And then we go back to the condition of the while loop. What is temp.next node now for the second iteration? This node now is our temp. So temp.next node this time refers to this one, okay, because this is our temp at this point. And what is that? It is equal to none. That is none. And so the condition is false. And so we don't execute anymore for the second iteration, this one. So there is no second iteration, okay? So the loop body was executed only once. And so we jump here. We create a new node of class type node, passing value. What is value this time? Value this time is equal to 3. So we have a new node. This is our new node, and the value of this new node is 3, and this is none. And then temp.next node, which is this one, will point to new node. Next node will point to this new node. And then the function returns the new node, which is this one. So right now, our singly linked list has 3 nodes. Then we go back to this. The fourth statement is a function call again to insert tail, and we want to insert a new node with value 4 at the tail of the singly linked list whose first node is L1. So in here, head is L1 and value is 4. We assign to local variable temp the head. Head is this one. Okay, so this is head. Then we say temp gets head. Then this is also called temp. And then we check the condition of the while loop. Temp.next node. What is temp.next node at this point? Temp.next node is this one. And we check that it's not none. And so the while loop body is executed. So we make temp to move to point to where temp.next node is pointing. Temp.next node is this one. At this point, temp.next node is this node because this is your temp.next node pointing to that node. We make temp to point to that, so we call this one now temp. So this is no longer, temp is no longer here. Temp is now in here. So this is now our temp. Initially, this is our temp, and then as long as there is a node on the right side, we move temp to that node. Okay, so what this while loop actually does, it is simply moving temp from the first node, which is L1, to the last node. Because we're going to insert at the tail, we have to find, or we have to position at the tail so that we could insert at the tail. That's the purpose of the while loop, to search the tail of the singly linked list so that from the tail we can insert a new node. Again, that's the purpose of the while loop in the code. So as long as there is a right node, we move temp to that. Temp is here. And after that, we move temp here. We go back to the condition. Temp.next node this time is this one. Temp.next node at this point is this pointer. And so referring to that node. So temp now is in here. So this is now the new temp. When we go back to this condition again, temp.next node this time is this one. That is now our temp.next node. And notice that it is equal to none. So the condition is equivalent to false. This is now false. And so we jump to this code, creating new node. Okay, we create new node. So this is now our new node. And the value of this is 4 and this is none. After that, this is temp.next node. We make it to point to new node by this statement here. And then we return new node, which is the new node that we have inserted at the tail of the singly linked list. Okay, so at this point, our singly linked list looks like this. Already it has 4 nodes. And lastly, we have this. Insert at the tail, the new element 5. We go back to insert tail, and this time head again is L1. And temp is set initially to head. So this is head. And then we jump to evaluate the condition of the while loop. Temp.next node. How many times is this condition true? Okay, this is the first time we check it, the second time, the third time. So it will be 3 iterations, right? Initially, our temp is at the first node. And then in the second iteration, since temp.next node is not none, we move temp here. So this is now our temp. And then when we check the condition of the while loop again, temp.next node is not none. It is pointing to a node on the right side. So we make temp to move there. So this one is now our new temp. And then we go back to the condition of the while loop, temp.next node, referring to this pointer, and it is not none. Therefore, we move temp to that node. So this is now our new temp. And then we go back to check the condition of the while loop, temp.next node. What is temp.next node? Temp.next node is this pointer, right? Take note, it is already equal to none. And so that makes the condition of the while loop false. We jump here. So we create a new node. So new node now is this one with value 5, and the next node of this new node is none. For this line, temp.next node gets new node. The temp.next node, remember that currently this is temp, and temp.next node is this new node. We make temp.next node to point to new node, and then we return new node. So notice that at this point, our singly linked list, whose first node is L1, has now 5 nodes. From L1, we have this as the first node, the second node, third, fourth, and fifth, the last. So this is returned, right? This is the one which recently returned. And so this one in here is the memory address of that new node with element 5. And then display list nodes simply traverse the singly linked list starting from L1, and as it visits a node, it displays the element or the value stored in that node, which is this part here, okay? 2, 3, 4, and 5. Okay, let's go to the definition of function display list nodes. So this is L1 head because that is what we pass in here as actual parameter. So this is L1, and temp is initially set to head. So initially temp is here, and then while temp, meaning while temp is not none, while temp is a valid memory address, we do this. So temp is a valid memory address because it is not none. It is a node. It has valid memory address. We print the temp.value. This is the value field, and this is the next node, right? So it displays the value of that. And then temp moves to the next node. So that is how you traverse the singly linked list starting from the first node. As long as there is a node on the right side, then we move temp to that node, and then we display temp that value. And then as long as there is a node on the right side, we make temp to move there, and then display the temp value, which is 3. And then since there is still another node on the right side, we make temp to point here, and then we display the temp dot value, which is 4. And lastly, we make temp to jump to this node, and then display temp dot value, which is 5. And since temp that next node is now none, temp also becomes none. And then when we go back to check the condition, it is already none. And so that makes the condition false, and the while loop terminates, and also the function. So what is the output of display list nodes L1? It is 1, 2, 3, 4, 5 because this is the first node that we visit containing 1, and then the next node we visit is containing 2 and 3 and 4 up to the last, which is 5. So again, the job of this function is simply to traverse the singly linked list from the first node up to the last node, and every node it visits, it displays the value or the element stored in that node.